Good morning, everyone. In this session, let us discuss the last concept of this unit 1, that is adversal search. In this adversal search, we are going to discuss about the perfect, imperfect decision game, evaluation function, and alpha beta pruning. So, what is this adversal search? It is a game playing technique where the agents are surrounded by a competitive environment. A conflicting goal is given to the agents. That agent may be a single agent or multi agent, and these agents compete with one another and try to defeat one another in order to win the game. So, such conflict goals give rise to the adversarial search. Here, game playing means discussing the games where human intelligence and logic factor is used. So, searches in which two or more players with conflicting goals are trying to explore the same search space for the solution are called adversarial searches, often also known as the games. There are different types of games, mainly deterministic games and chance moves. In that, there is perfect information and imperfect information. So when we see deterministic and if it is perfect, we can take example as chess, checkers, go. And if it is chance moves games, then it is backgammon and monopoly comes under chance moves and with the perfect information. And coming to the imperfect information, these battleships, blind and tic-tac-toe comes under deterministic. And bridge, poker, Scrabble, nuclear war, these are all comes under the chance moves. These are the some of the types of games in AI. So what are these different types of games? What is this perfect information? A game with this perfect information is in which agents can look into the complete board. Means agents will have the all information about the game, and they also see the each other what moves they are making. So examples you can take it as chess and checkers. Whereas coming to imperfect information, if in a game, agents do not have all information about game and not aware what's going on. Such types are called as generally game with imperfect information. We can take the best example as tic-tac-toe. Next, deterministic games. Deterministic games are those games which follow a strict pattern and set of rules for the games. And there is no randomness associated with them. So we can take example as chess, checkers, and even tic-tac-toe also comes under this deterministic games. And coming to non-deterministic games are those games which have various unpredictable events, and here there is a factor of chance or luck. Okay? That is that a factor of chance or luck is introduced by either by dice or cards, which we play with dice or cards. So such things generally we call it as the non-deterministic games, or we can also call it as the stochastic games. So these are some of the information regarding these different types of games. Let us see the next one. Techniques required to get the best optimal solution. There is always a need to choose the algorithms which provides the optimal solution, that too within a limited time. So there are two techniques which could fulfill our requirements. One is pruning and other one is the heuristic evaluation function. So what is pruning? A technique which allows ignoring the unwanted portions of a search tree which make no difference in its final result. Means we need not to travel into throughout search space, which is not required. We can prune that one, but there will be no difference in its final result. That is what we call it as a pruning. It is one of the technique. Another one is the heuristic evaluation function. It allows to approximate the cost value at each level of the search tree before reaching the goal. Okay, approximation of the cost value at each level of the search tree before going to the goal node. That is what we call it as the heuristic evaluation function. Then coming to the even for the adversarial search also, there will be a formalization of the problem. So a game can be defined as a type of search in AI which can be formalized with the following elements. That is initial state. We know that specifies how the game is set up. The game setup at the starting level, generally we call it as the initial state. Players, it specifies which player has moved in the state space. Actions, it returns the set of legal moves in state space. Okay. Then result, it is the transition model which specifies the result of the moves in the state space. Then comes terminal test. It is the True if the game is over, else it is false at any case. So the state where the game ends, generally at the end of the game, generally we call it as the terminal state. And then utility function. This is one of the important one in adversarial search. It defines the final value with which the game has ended. Okay. So once we have finished the game, generally a player will lose the game or win the game, or maybe there may be a draw between the players. Those are all nothing but the utility function. So this function is also known as the objective function or the payoff function. And the price which the winner will get is minus, if the player loses, will get -1. If wins, +1. And if there is any draw, it gives us a 0. Then let us discuss about the game tree. A game tree is a tree where nodes of the tree are the game states and edges of the trees are the moves taken by players. And what are the types of algorithms in this adversarial search is, in a normal search, generally we follow a sequence of action to reach the goal or to finish the game optimally. But in an adversarial search, the result depends upon the players, which will decide the result of the game. Generally, there are two types of adversarial search. One is the min-max algorithm, other one is the alpha-beta problem. So these two algorithms are used for generally game playing or adversarial search. So when we see a game tree for tic-tac-toe, you can see this one. So this is the state space representation of a tic-tac-toe, where there we know that students, you are aware of how we are going to play tic-tac-toe. That is, we require two persons, maybe one ourselves, human being, we are going to play with a machine. So there will be two players. That players generally we call it as the max, and other player is min. Maybe we are the max, we are starting the game, human being is a max, and the machine may be the min. So next turn will come to max. After max, next min. Like that, this the tree structure represents how this is for tic-tac-toe. And at last, we'll reach to the terminal state. If, see here, if min loses, it is -1. If it is draw, 0. If max wins, it is plus. So this is the utility function. So here, the initial state, the top node in the game tree represents the initial state, that is this one. Okay. Then players, I already told you there are two players, one is a max and one is a min. And always remember, max begins the game by picking one best move and place X in the empty square box. Actions. Both the players can make moves in the empty boxes chance by chance. That is nothing but the actions. Okay. Then result. The moves made by min and max will decide the outcome of the game. Terminal test, when all the empty boxes will be filled, then it will be the terminating state of the game. And at last is the utility. We can see here the utility. At the end, we will get to know who wins, max or min, and accordingly, the prize will be given to the player. So now, let us discuss the min-max strategy. So, or the min-max algorithm. In artificial intelligence, min-max is a decision-making strategy under game theory. That is, which is used to minimize the losing chances in a game and maximize the winning chances. Try to understand, minimize the losing chances and maximize the winning chances. And it is a two-player game strategy. If one wins, other, yes, definitely lose the game. So there are two players, that is min and max. So min will decrease the chances of max to win the game, and max increases his chances of winning the game. Try to understand, min decrease the chances of max to win the game, whereas max increases his chances of winning the game. So in this min-max strategy, the result of the game or the utility value is generated by a heuristic function from the initial node to the root node. And one more important point regarding this min-max strategy is it follows the backtracking technique, that is, and it backtracks to the find the best choice. Okay. So in the next session, we are going to discuss this min-max strategy or min-max algorithm with one example.